Hello guys, welcome to the channel. In this particular video, I will explain the problem longest palindrome in a string. So the problem is a standard DSA problem and asked by companies like Samsung, Google, Amazon, Microsoft, etc. So let's start with the problem statement. Here is the problem statement. It says that you are given a string S and you have to find the longest palindromic substring. What is a substring is given here. So one more thing is, what is a palindromic string? So a palindromic string is a string that reads the same as backwards. Let me explain this. So if I write a string, let's say race car. So for this string, if you read this string from left to right or right to left, the string will reads the same. So such type of string is known as a palindromic string, right? More formally, S is a palindrome if the reverse of S is equal to S. So again the same thing. If you reverse this particular string, then you will get the same string, right? Now it says that okay, so we are given a string and we have to find the longest palindromic substring. One example is given here. Let me explain with this example. So we have a string which is A, then we have B, and A. For this string, there are multiple substrings possible, right? And out of those substrings, there are multiple substrings again which are palindrome. For example, A is a palindrome, then AA is a palindrome, then AAA is again a palindrome, and then like ABBA is a palindrome, and one more palindrome is AAA, right? But out of like every possible palindrome, you can see that the longest is this one. The length of this palindrome is 6 and this is the longest palindromic substring present in this string. So you can see that the output is here, right? And now I hope you have understood the problem statement. So let's talk about the solution now. Okay, so after looking at the problem, the first approach that will come to your mind is we can try out every possible substring, right? Let me take the same string as example. So we have A, then B, then A, right? This is example. So for this, we can try out every possible substring. How we can do this in code? We can simply run two nested loops for I equals to 0. And so let's say I have I here and J here. So this is how I will get the like possible substring, and we can move this I and J every like at every point. I can move I here, then J here, but one condition is I will always be less than J. This is very important, and you can see that this the same thing is given here, right? This is so now I can simply run two nested loops for I equals to 0. I is smaller than like length of S and I plus plus. This pointer is going to iterate from this position to this position. Now I will have one more loop and this is for the J pointer. So J will always start from I. Let's say I have I here, so J will start from I and J will keep expanding from I to J. So J equals to I, then J is smaller than length of S again, and then J plus plus. This way I can get every possible substring inside this, right? Now what I'll do is I'll get the current possible substring. So current substring is substring equal to, I have a function which is substr, then from I to j. This will give me a possible substring which is the current substring, right? I just need to check one thing, if it is a palindrome. So if palindrome substring, the current substring. So if it is a palindrome, then I will check one more thing. Why? One more thing is if the length of this substring is greater than the length of answer. This is really important. This is really important because I need to keep track of the longest substring, right? So that's why I have a string here which is the answer, and then I'm simply going to update the answer. This is how I can write the first approach, and at last I just need to return the answer. So this is about the brute force approach. What is the time complexity? The time complexity will be, so let me change the color first. I have O of n loop here. Then again I have one more n loop, and this is nesting of loops. Inside this I have O of n function, which is substring. The substring function takes O of n time to get the substring, right? And after this particular function again will take O of n complexity. What is this function? Palindrome. So let's say I have a string which is okay. So let's take this particular string. I have A. Then in order to check the palindrome, we just have two pointers and then we keep moving these pointers, right? Like these two are equal, then I will move here. If these two are equal, then I will move here, and this is how I check. So again, the complexity is O of n. So the total complexity of this approach will be O of n cube. Why n cube? Because I have two nested loops. Inside this I have O of n plus n. O of n plus n. So the complexity will be similar to O of n cube, right? And this complexity is not going to work for the large inputs. So this is not the optimal approach. Now let's talk about the optimizations that we can do in order to understand the optimal approach. So first of all, let me write an example. I'm going to take the same example as given in the problem statement, or let me take another example. So I have a b a, then I have a b b a a, then I have b a, right? Let me take this particular example and let me write optimal approach here. Optimal approach. Now for this example, in order to understand the optimal approach, let me talk about two important like type of palindrome. So the first one is a odd length palindrome. So in order to explain this, I'll write x y x. So this is one of the palindromes, and the second is x x y y x x. This particular palindrome is an odd length palindrome, and this is even length. So what's special about odd length palindrome is we have a single middle element, and then we just keep expanding and checking the equality of elements. Like these two are equal and these two are again equal, you can see that. So this is how a odd length palindrome looks like. And for this like even length palindrome, we have two middle elements and those two middle elements are equal, then we keep expanding, right? This is how we check a middle a even length palindrome. The same approach we can use here. What we can do is we can iterate from I equals to 0 to I equals to n minus 1, and I can take every I as the middle element. So let's say I am somewhere in the middle. So how I can check for the current position of I will simply take this as the middle element. So if this is a middle element, then I'll start from these 2 points, isn't it? You can see that this is a middle element. I'm starting from these 2 points. I'll check, are these 2 points equal? No, these are not equal. So we have only one middle like one palindrome here, right? Palindrome of length 1. But what if I take these two middle elements? So if I take these two middle elements, then I'll keep expanding, right? You can see that for this case I have these two equal, then these two equal, then these two equal. This way I'm able to get a b b a a. And notice one thing, that I have not changed the position of I. The position of I is same here, right? So this is how we can check. Even from this position, again I can do the same thing. I can consider for length, odd length palindrome and even length palindrome, right? And for this position, you can see that if I consider even length palindrome like odd length, then I'll start from these 2 points, and these two are not equal, so I have only a. But if I take even length, then I have these two, and these two are equal, right? So this way I'm able to get b a a b, something like this, right? So this is what we can do. How we can do this? I can simply run a loop. So let me copy this particular example. Very important example, guys. Okay, so let me remove this. I simply copy this particular example. Now I can write the pseudocode. So the pseudocode will be, I have I, right? So I'll start I equals to 0, and I need a start and end. So start equals to 0 and then end equals to let's say end is equal to 0 again. So what I'll do is I'll write while my I is smaller than n. So what is n here? N is the length of this particular string, right? So n equals to length of s. Simple. So inside this loop, I'll simply check for odd and even length. So for the odd length, what we do is I have the current position of I, then I start from the I minus 1 and I plus 1. This is for odd length because we have middle element like only one of length 1. So I'll start j equals to I minus 1 and k equals to I plus 1, and I'll just keep expanding. J will move this side and k will move this side, and I'll check both elements are equal or not. So I have again one more while loop. So inside this, j is equal to 0 and k is smaller than length of s, right? And one more thing is s of j is equal to s of k. This is how we check. You can even notice here that we have like we start from these two positions, then we check like these two are equal or not each time, right? And we keep moving the pointers. So it is like expanding. So what I'm doing is I'm simply doing j minus 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 and k plus plus. So this is what I can do, and when this loop completes, then I will have the palindrome of odd length, right, from the current position. So now I just need to do one thing, that I need to check if my like length of, if my k minus j plus 1, this is the length of k, is smaller, is greater than end minus start plus 1. This is what we can do, and if this is the condition, then start will be equal to j and end will be equal to k. And similarly I can write the same code, but I can change the position of j and k. So I can now do j equals to I and k equals to I plus 1. This is what I can do, and this way I will be able to get the longest palindrome. So the complexity of this approach will now reduce to O of n square. Why? Because for each position of I, which is O of n, I'm just expanding like this. So let me show you the code. Let me show you the code. This is the code. On the left hand side I have Java code, and on the right hand side I have the C++ and Python code. So you can see that I have pull start and end, then I'm just keep for each position of I till n, I just keep expanding, right? This is for the odd length palindrome, and this is for even length palindrome. And you can see that at last I'm simply returning the substring, right? I have the starting and end point. And similarly I'm doing the same thing for the C++ code and the Python code. So this is all about this problem. I hope you guys will like the explanation and the solution. Thank you.